Okay, first off in this lesson, I want to show you the sine, cosine, and tangent values of 0, 90, 180, 270, and then 360, which is the same as 0. But I want to show you that, and I want to describe why those values are at. Right here, I have just an interactive unit circle. You can ignore this stuff for now. We'll get into the graph parts after a while. But just look at my unit circle now, and we've talked about central angles. Here I have a central angle right here, all right? And we've talked about creating our right triangle in order to find our sine, cosine, and tangent of an angle. Well, okay, so notice now here, the gray line here is my hypotenuse. The red line here is my opposite side, and the blue line here is my adjacent side. So watch as I go to put my triangle on 0, I notice that my opposite side disappears. So my opposite side goes to 0. So that would make sense as to, I can't get up and show you and highlight it. That would make sense to why the sine of 0, if you look up in the upper corner where it's giving you the sine readouts, is 0. All right, so like my opposite side is 0, and sine is opposite all over hypotenuse. So it would be 0 all over my hypotenuse right now is 1. It goes all the way over there. All right, my hypotenuse there is in the unit circle. My hypotenuse is a radius. It's 1. So 0 over 1. So the sine of 0 degrees is 1. All right, in the same respect, cosine, all right, cosine is the adjacent side. Notice my blue line is still there. My blue line right here is still there, and the hypotenuse is laying on top of it. That value is still 1, so we have 1 over 1. That's why cosine of 0 is 1. The adjacent side is still there. The hypotenuse is laying on top of the adjacent side. And then tangent is 0 because my opposite side, my red line, is 0. So I have 0 all over 1, which 0 over 1 is 0. So the tangent of 0 degrees is 0, the cosine of 0 degrees is 1, and the sine of 0 degrees is 0. So if we come back up here, notice now what's happening is as I get closer and closer to 90, my adjacent side is disappearing. My opposite side is going to be laying right over top of the hypotenuse here pretty soon. And so what that means is that the sine opposite, my opposite angle is 1. My opposite side is 1. It's going from the center of the circle all the way to an outer part of the circle, which makes it a radius. So my opposite side is 1, and my hypotenuse is 1 because the hypotenuse is never disappearing. It's just this gray line right here. So I have 1 over 1 for sine, opposite all over hypotenuse. That's why the sine of 90 is 1. Cosine is 0 because you see now as I get closer, my adjacent side right here, my blue line is disappearing. So my blue line is going to 0, so the cosine of 90 is 0. Now you're asking, why is tangent undefined? Well, tangent is opposite, so the red line all over the blue line, so opposite all over adjacent. So in this case, I have my opposite value is 1. The red line's value is 1, and the adjacent value is 0. So 1 over 0 would make that undefined. So moving on to 180 degrees, now you notice, again, my opposite side is disappearing. The closer and closer I get to 180, the red line is disappearing, and again my hypotenuse is going to fall right on top of my adjacent side. So it's going to be very similar to 0, the ones we had at 0 degrees, except for now we're on the negative side of the axis, the coordinate plane. So now the value of my blue line is -1 as we get out to 180. So the value of that blue line is now -1, and the hypotenuse is +1. So that's why cosine is a -1. So the cosine of 180 is a -1 all over 1. Adjacent is -1, hypotenuse is 1. And again, the opposite side disappeared, so we have 0 divided by 1. Opposite over hypotenuse is sine. So that's why that is 0 degrees. And tangent is also 0 because it's opposite all over adjacent. The opposite value, the red's value, is 0. And the blue's value is 1, so 0 over 1 is 0. And then going down to 270 degrees. All right. 270 degrees, notice again that my blue line, my adjacent side, is disappearing, and therefore that's going to make my adjacent side 0. So sine, opposite over adjacent, or sorry, sine is opposite over hypotenuse, is going to be 1 over 1, except for now we're in the lower part of the coordinate plane, so that's a negative 1 over 1. So the sine of 270 is negative 1. The cosine, again, look, as my blue line disappears, my blue line is 0 adjacent over hypotenuse, so it'd be 0 over 1 is 0. And tangent is undefined because it's opposite all over adjacent. My opposite value is negative 1. My adjacent value is 0. You cannot divide by 0, so therefore it's undefined. And then obviously 360 is the same thing as 0. Okay? So let's move on to some examples I have. And then also, if you wanted to find the values for like cosecant, secant, and cotangent of 0, 90, 180, 270, and 360, you can do the reciprocals. Now, keep in mind the reciprocal of something undefined. So the reciprocal of something undefined is, this is undefined on this side, but if we do the reciprocal, all right, I have 0 over 1, which is 0. I shouldn't have the equal sign. The reciprocal of that is 1, 0. So the reciprocal of undefined is 0. The reciprocal of 0 would be undefined because it'd be 0 over 1. If we flip that around, we'd have 1 over 0, which is undefined. So that's basically the biggest thing that comes out of that, is if we have an undefined function, then if we do the reciprocal of it, then it is 0. And if we have a 0, the value is 0, and we flip it around, it's got to be undefined. Okay. Two more things to add to the back of your unit circle. You're going to want to write these down. Special right triangles. We've done a little bit of this. I think we did it in geometry. But these are special right triangles, a 30, 60, 90 triangle and a 45, 45, 90 triangle. Knowing these shortcuts is going to make knowing the sine, cosine values of these angles much easier. So what this does is I can find the sine of 30 degrees real easy. The sine of 30 degrees is opposite all over hypotenuse. So sine of 30 is 1 all over 2, so 1/2. Or I can find the cosine of 30. So adjacent over hypotenuse, the square root of 3 over 2, and the tangent and so forth. So I can use this triangle for every angle that's 30 degrees, 60 degrees, and I can use this triangle for any angle that's 45 degrees. Okay? So let's keep moving on. Find each value, cosine of 5 pi over 6. Now, we had you earlier, sorry, computer's going crazy here. All right. We had you earlier find the, there we go, find the reference angles for certain angles. So what we're going to do, we're going to use our right triangles to find the reference angle. So 5 pi over 6 is definitely not a full rotation, because if it was over 6, it would have to take 12 pi over 6 to go full rotation, and it's not quite to 180. So 5 pi over 6 is right here. It's just about to 180, and that guy's reference angle is pi over 6. All right, so we're dealing with a 30 degree. This is my 30, this is my 60, and this is my 90. All right, so we're dealing with that special right triangle. So if we want to find the cosine of it, we just draw our special right triangle. Opposite of 30 is 1, opposite of 60 is square root of 3, and the hypotenuse is 2. So to find the cosine of 5 pi over 6, this is actually a negative square root of 3 because we're moving in the negative direction on our coordinate plane. All right, this is still positive because we're going up on the coordinate plane. So the cosine value of 5 pi over 6 would be the adjacent, negative square root of 3, all over the hypotenuse, which is 2. So this cosine value is negative square root of 3 all over 2. Okay? So if we wanted to find the tangent of 11 pi over 4, so first of all, we got to figure out where negative 11 pi over 4 is at. Remember, the negative sign indicates what direction we're going around the circle. So if I go around halfway here, that would be 4 pi over 4. So that means I have 7 pi over 4 left. So I can't quite go, or actually, yeah, I can go another 4 pi around here. So I made one complete circle. So now I have 3 pi over 4. And 3 pi over 4 is almost 180 or pi, so it's almost there. So here is our angle right here, and if we're talking about its reference angle, how far is it away from this pi right here? Well, it is pi over 4 away. So now we're dealing with our other special right triangle, which was the square, which was the square root of 2, square root of 2, and 1, I believe. We better check that real quick. I'm pretty sure that's correct. Oh, sorry, 1, 1 and square root of 2. So I messed up. 1, I knew that didn't seem right. 1, 1, and the square root of 2 is the hypotenuse. So now this value is in the negative direction of my coordinate plane, so it's got to be negative, and this value is going down, so it also has to be negative. All right, so if we're finding the tangent is the opposite, so negative 1 all over the adjacent, which is also negative 1. So the tangent of negative 11 pi over 4 is a positive 1 because it's a negative divided by a negative. Okay. So the sine of 7 pi over 4. So first off, we got to figure out where that angle is. It is almost 1 full rotation. 1 full rotation would be 8 pi over 4, and it's not quite that. So this has got to be almost a full circle, but not quite. It's actually pi over 4 short. So pi over 4 is my reference angle, which tells us what special triangle we're doing. We're using now I'm going to label it right, 1, 1, square root of 2, special right triangle. And again, now we got to make sure our positive signs are right. So this is in the positive direction on the x-axis. This is in the negative direction, so this is a negative 1. So now we're looking at the sine. The sine is opposite, so negative 1 all over the hypotenuse, which is the square root of 2. So we don't like square roots on the bottom, so let's go ahead and simplify this real quick by multiplying both the top and the bottom by square root of 2. That just gets rid of my radical on the bottom. The square root of 2 times the square root of 2 is the square root of 4, which is just 2. And then a negative 1 times the square root of 2 is negative square root of 2. So the sine of 7 pi over 4 is negative square root of 2. All right, for time purposes, I'm going to stop right here. You guys can continue on and do these if you would like. But for time purposes, I'm going to stop here. I think you get the point. And if you guys are step people, the first thing you want to do is you want to find where the angle is at. And then you want, in doing that, you want the reference angle. And from the reference angle, you're going to draw your special right triangle. Draw special right triangle. All right, and then third, you're going to want to check your signs, make sure you have positive and negatives right. And lastly is perform the trig function that's asked. So if they're asking you to do sine, do opposite over hypotenuse, cosine adjacent over hypotenuse, and so forth. Okay, so that's the step in case you guys are step people. And what I'm going to have you do in class is there's a table on page 265, and what you're going to do is you're going to complete that, and you're going to add tangent of theta, and you're going to do that all the way to pi over 2. But you're going to do that in class. I hope this helps. We'll see you in class.